Hello, everyone. I prepared this presentation in English. If anyone has any trouble with that, please let me know, and I'll try to accommodate as much as possible. I want to talk to you about the least privilege principle. But first, let me briefly introduce myself. My name is Lino Urdiales. I am a Barcelona-based software engineer. I work at Grafana Labs, and I am also part of the identity and access management squad. What we do is basically we make sure that everyone has access to the Grafana cloud services, and they also have access to the Grafana platform, the application. Um, Anything related with access policies, and also we provide support for infrastructure as code. What is the least privilege principle? The least privilege principle is a security concept. This is what we IT experts and security professionals. This is what we talk about in terms of less is more, and the less access we give away or we grant to users, to specifically to the resources, in the unfortunate scenario that that account might get compromised, is the less access that they're going to have, like damage of. Just imagine the scenario where someone steals your credential or someone steals an access account for an account. Again, I'm going to try to speak about this concept kind of broadly. If anyone has any questions about the technical terms that I'm using, please feel free to interrupt me so I can give out more clarification about this. So this is a quote from Anna Belloc. She's the director from the cybersecurity strategy at SysDic. What she says is, I am disheartened by the massive number of excessive permissions being administered, especially for machine identities. Now, we work with technology and we tend to automate a lot. This is something that I have seen that a lot of us do. If something needs to be done more than 3 times, we're going to automate it. But what is the problem when we start automating things? It has come with like some costs and some caveats. Is that sometimes we grant the automation way more privileges than a regular user has, or even more, but especially more privileges that that these service accounts or automation actually needs. So why is this a problem, or how excessive is excessive? Well, this is just to show you that on an analysis that they have made, especially a postmortem on incidents, they have found out that 98 permissions that are granted to service accounts are not needed. They could continue keep doing the same task with just a 2% of uh, with just a 2% of the permissions needed. So what is this? This is just picture this scenario in your head. We have a service account that its purpose is to update an entry on a database. You know, the sales table, for example. Um, does that service account need access to the full database? Need full control to the database? No, because what would happen if someone gets and steals the credential of the service account? Well, they can take a look at more information, the users table, who has access, the logs, anything that can be stored in that database. So what we're trying to do is limit the scope. Why, if someone steals the access token to update the sales report, is going to have access to the employees roster. It's going to have access to the business strategy of the company. And that's how things get to escalate, and that's how I end up stealing all of this information. So let me list some of the key benefits of adopting the least privilege principle. Again, looking into this scenario where a compromised user account or even a container, we want to stop them to be able to access or modify or even delete information that they in a malicious attempt. So risk mitigation, again, this is, yes, a service account for monitoring sales report got compromised, but that account shouldn't have access to anything else. So if the token gets stolen, they're not going to have access to still roster information or sensitive information like, I don't know, bank statements or credit card details. This also means the reduced attack surface. This stands for avoiding escalations from a compromised position. This is true sometimes because some of these attacks not only steal the information, but also they end up gaining access to other services or auto grant auto grant permissions to access to more resources. If you have ever done any of those hack my box type of drills, they give you this virtual machine that you have to learn how to like hack your way into it as part of the exercise. Well, imagine an attacker has scripts to do all that in a way that is like a quickly fast, and they can do as much damage as possible with a very small time window. And another key benefit of adopting the least privilege principle is the adoption of security standards like GDPR and HIPAA. We all have gone through those certification tests. They take a lot of time, but it's not only, we don't not only have to comply because of the certification or the test. We also have to put those principles in practice. So what does this look like in practice? Well, these are just a few examples. This is not limited to, but just to show you like how this looks like. Granting access upon request. You could have your users request through a form what kind of information they want to get access to and with what purpose. So this is going to help us keep an activity log and monitor why this person is going to access some permissions. And even if we automate the granting access for, I don't know, let's say a specific team, at least we're going to have a detailed log of what, when, what, and why of this access. RBAC, this is role-based access control, and this is going to be the best way to so we can handle the relationship between permissions and users. So what RBAC does is basically it compiles all the permissions into roles, and those roles get assigned to the users. But instead of assigning the roles directly to the users, we should go a little step forward and assign these roles through groups. So the only way a user can have access to any information is by belonging to a specific group. And why do we want to do that? Because A, it's going to be easier to grant permissions to some groups, I mean, permissions to some users. And the other key factor is that if a user doesn't belong to any group, he's not going to have access, or he shouldn't have access to any of this information. And last but not least, temporal access. Just because we grant access to someone, it doesn't mean that that access needs to be stay there forever or for a whole month. Like if someone needs to make changes to production, well, we're going to give him a time access, let's say 1 hour, 30 minutes, whatever he needs, but something that is reasonable, something that works for you, for your organization and your developers. Keep in mind that this is what it looks in practice. You need to adopt it and adjust it according to whatever your organization looks like. Again, just to reiterate a little bit on this, we need to be able to also audit the permissions that we have, especially for any automated services that we use. So this means that does this specific service account needs all this collection of permissions? Does this service account actually needs like this amount of permissions? This is going to change over time. That's why we need to review this on a regular basis, not just one time and then it fits all. Again, grant log any access that is being granted. And one last word of advice: ephemeral containers don't guarantee safety. Again, I told you at the beginning that attackers have like tools to automate all these attacks. So this also translates that, an ephemeral container that lasts 1 day or lasts for 1 hour might be way too long. Some of these attacks can take as little as 10 minutes in order to steal and compromise your information. And this is why we need to grant access only when it's going to be used and nothing else. So just to wrap it up a little bit, I am not here trying to create fear monger, but rather to give you a word of advice. Take a look at your infrastructure. Take a look at what is your current situation. find the balance between security and productivity, because also developers need to keep a specific pace. But imagine within your own infrastructure, what is the worst case scenario? Become a little bit paranoid about it and think about what could be the worst case scenario, and on the weakest link, even if it's a few chance of that happening. Don't rely on security by obscurity. Reinforce your own security practices. Not only is the information that is being at risk here, it's also the reputation of the companies. It's also the reputation of us as developers. And there could be like blackmail, ransoms. There's a lot of bad, really terrible consequences that can come out of this. Okay. Thank you for listening to me. And if you have any questions, I will be around. And have a great day. Yes.
So this is tied together with network segmentation, usually some companies
Exactly.
practice.
Exactly.
The problem I have I have operated a couple of big data clusters where people try to get data in and out a lot. The problem I have with all of these is the manual steps of requesting permission. Isn't there any piece of software, and maybe it's $1 million idea or $1 billion idea, right? That analyzes the different requests that the machines do or the people does, and then pops up an alert. Hey, sort of a second factor authentication. Hey, is this you logging in? Is this you requesting this permission? Yes, granted for everyone. Yes, granted for 1 hour. Yes. Isn't there something that can ease the usability and the maintainability of
I mean, there are a lot of different solutions. For example, Okta also provides like some granting access and solutions depending on a timely manner. But that's a balance that you need to find out. And I agree that it's an obstacle. Even us as developers, I need to like check the email, and I have to go through like 7 steps with password and also my fingerprint and everything that is involved. I can imagine it's the same for deploying infrastructure. So you can, I mean, I'm not trying to say one solution fits all, but you could also automate granting access, obviously with its own risk, but at least that's going to also give you a log about each of the activity, and that's activity that you should monitor. And combine that with more practices. So let's say I'm only going to do deployments between 5 a.m. and 5:30 a.m. So any deployment that goes outside of that scope, that should raise an alarm. That should raise an alert that someone needs to be patient immediately and take a look about what's going on, where that access came from, and with what credentials. And maybe also make those credentials only valid for that specific amount of time. First in the back.
Voy a hacer la pregunta que se llama.
Dale.
¿Tenéis algún sistema de baking labs para escalar permisos si hay algún developer que necesita hacer, porque se ha roto algo y lo tenéis muy capaz?
A ver, yo trabajo con la parte de Grafana del Codebase en general. Entonces, para este tipo de soluciones de infraestructura y cómo otorgar permisos a los usuarios, no conozco de momento. Si alguien más aquí sabe, por favor que también participe. Pero si no, te lo puedo buscar y responderte, aunque sea de forma asíncrona. ¿Vale? Gracias. ¿Y?
First of all, thanks for the brief to the point presentation. Very interesting. I'm really shocked by the 98%. I can definitely recognize that we have excessive provisioning all over the place, especially in a pre-cloud world, in the more traditional type of systems. I work in the banking industry, by the way, so I've seen a lot of these. Now, you did mention earlier, as a kind of reaction to the previous question, that one of the reasons of being indulgent with the permissioning is that requesting new permissions or changing, I have this need as well, I have that need as well, tends to be very manual, tends to be a process which is time consuming, annoying, and people feel slowed down. Therefore, they insist on getting a little bit more initially so that they don't need to bother again. the person or the system that has to permission them new permissioning, so new access. Beside this reason, what other reasons you have seen that makes this 98%, 98%?
A lot of that has to do with, for example, out-of-the-box solutions. So this is just one example, but we can extrapolate that. Grafana, for example, it comes out of the box with 3 different roles: viewer, edit, and admin. Those 3 roles have a very broad collection of permissions. So if I create a service account and just automatically assign it the admin role, this is going to give that little service account way too much power for what it's actually going to do. And I feel like this is one of those reasons that, trying to answer your question, we're trying to find a one size fits all. Something that I also forgot to mention is another reason would be to create, let's say, a service account role and use that role for all my different service accounts. A better solution would be for each of the service accounts, they should have a very specific role with a very specific collection of permissions, and they shouldn't be overlapping. Maybe if they do something similar, then maybe it's okay that they overlap, but they shouldn't be sharing the same access to the database tables, for example.
I agree with you. Sorry to just come back on this, because speaking with my security colleagues in the past, they struggled quite a bit to manage very fine grind roles, because this RBAC is very powerful, very good, probably better than the previous attribute base that was used in the past. But the more granular you make it, so that you bring back to your point here, the very like as needed only, then it becomes a management challenge to manage the so many roles. Then it's going to be really difficult. And because humans manage these roles normally, even with the automation, whatever, they still struggle and get confused. So how can we balance this management need with the provisioning to only what we need to access?
I guess it really depends on the deeper dive into your own needs as organization. I feel like from, let's say, a technical standpoint, like, oh, we don't have an out-of-the-box solution to fix this problem, because I agree with you, it's an obstacle that we need to overcome. But only by taking a deeper look into, okay, why having so many roles it's bring such a big obstacle, or maybe why do we have so many obstacles? Maybe we need those 500 services that we need to query every day, or is it possible that we can reduce a server account, or maybe not? Again, it's really hard for me to kind of come up with this is the one solution that everyone should follow. This is the principle that we should abide by, but it does offer, it does bring the obstacle. And then the other thing that we should take a look at is how much are we losing by spending time into looking into all these roles, and how much are we going to lose if the information gets compromised. So you were saying that you work in finance in bank, or that's what you mentioned previously. I guess that the consequences would be very dire in bank than, I don't know, it's just my little project to check what's the humidity of my plants. You see what I mean?
Sure. What are you thinking about Zanzibar and 58 fine-grained authorization?
This is something that we have seen companies are trying to move into that direction. I know that Okta and also some people at Grafana are looking into, with OpenFGA, and basically change this model into a more a federation approach. I haven't seen anyone finish an implementation or brag about the implementation. So far, I only seen like first steps about the Zanzibar research. It looks very promising, especially on the technical performance that it's going to bring when you need to do a reverse lookup of which permissions belong to does this user has access to. So it does bring a lot of performance improvement, but you need to basically start redoing or restart reassigning all of these roles. But it looks very promising. Right now, we are trying to get moving to that direction, but we still are not like fully there.
Yeah, I was thinking maybe because of OpenVDA, there is another one I don't remember now.
Mhm.
Also implemented, they have CDKs for any languages. Also you can do API calls, I think.
I think that also Google did something very similar for the permissions on the folders and for Google Drive,
Yeah.
and that's where this Sensiver project actually started to like take off. Good question. You had a question?
Yeah, and I try to follow on the need of creating a lot of roles. Maybe sometimes you don't need to create roles, but use API keys that when you create API key, you just put your, I just need that for 1 hour. And so you don't have to create roles. So sometimes there's weight of not creating roles and a lot of roles for all your stuff if you use other way of accessing your data, like API keys where you can create an API key with just a reduced scope.
Sorry, can you repeat the question again?
No, it's not a question. It's just
Oh,
a follow up.
Okay. Oh, thank you. Sorry, I got a little bit lost. I was expecting a question and it never arrived. Thank you.
Just so I'm working for Elasticsearch for Elastic. So in Elasticsearch, when creating an API key with a scope,
Exactly.
So there's no roles associated to it. So we don't need to create a role for everybody.
Exactly. The keyword here is scope, and the more reduced the scope is, the more control we can have this collection of permissions and access. If anyone has, yeah, you have an answer?
I have an answer.
Good.
I'm a product manager for Grafana, and I am currently working on a big project on the POC of Kubernetes. So I think in 6 months, there might be something
Because I have in the queue, because we need to implement it in my company also.
No, but if you have questions, you can ask me that on what are we doing and what things we are considering as
I was afraid to break NDA or something. That's why I didn't want to commit to time frame.
You have permission now.
Yeah, now I have. Now the official answer is 6 months.
you have permission, like,
Temporary permission.
question again in 6 months, to see where we are.
Do you want to talk about it in March?
In 6 months, maybe.
That would be fun.
Let me see how I implement later too.
So if anyone else has any other question, or you can, yes, please.
Yeah, maybe from the other side, because I work at CrowdStrike, so we actually work with partners who have all these problems. 80% of everything is happening is this thing. So identity, role stuff that people forgot. I also work as a developer. Also in cloud, though it's a mess sometimes because you have no time, no resources. You do this stuff, you just use the preset of AWS, whatever it works, and then magically something goes wrong.
That's also one of the obstacles that I've seen in terms of improving security. It's not a priority, and this security concern ends up becoming technical debt, and that's what it shouldn't be. We should like prioritize it. We should like vouch for it, and we should put pressure as developers, because the consequences can be very dire. And this is not it happened something very small when we now need to address it. No, like when something breaks in terms of security, it's really broken, right? Okay, thank you so much for your time, and I'm gonna keep now room for Dimitri.
Another way I like to call it is how to transition to multi-arch cloud native architecture without losing your mind. And this is going to be half theory, half demo. But before that, I'll present me a little bit. I'm the founder of Harbor Cloud Solutions. I started a cloud native consulting company 10 years ago. I was previously Docker captain. I was organizing Docker and Kubernetes meetups. Now I left most of the work to Christian and Ima for the cloud native one. I'm a member of Google Cloud Innovators. And currently I'm working as platform engineer. My client is the SVB company, which is the Swiss trains, basically. And what we do in our team is we manage in Kubernetes/OpenShift architecture, we manage Postgres instances. And if someone says we only run Kubernetes in Kubernetes stateless stuff, that's not true. Postgres can run very well in Kubernetes infrastructure, and we run it in Amazon, Azure, Swiss Cloud, in multi-cloud infrastructure, and we abstract using Kubernetes so that we have all the instances there. So we have about 800 instances, 3 terabytes of memory, 1,500 CPU, well, a lot of infrastructure. So my presentation here is about what is ARM, why use ARM instead of AMD/Intel, how to transition in production, and at the end I'm going to do a quick demo to show how that can be done. So first of all, the what is ARM? Well, ARM is this thing. It's a CPU architecture. It comes in different sizes and shapes, but basically what it is, it's a CPU. It's different from AMD and Intel because the architecture is different. We're going to talk about what the difference is. But this is basically a table of different CPU architectures. And first line, when you download a binary from GitHub or from somewhere, probably you will find the CPU architecture on the left side. And basically those map to one of the instances that, one of the different CPU architectures that exists. May be confusing, but x86_64 is the same thing as AMD64, for example. And what I'm talking about is the ARM64 or ARM in general. So what's the difference between ARM and AMD or Intel architecture? The ARM architecture is RISC-based. Basically, it's reduced instruction set computing. And AMD/Intel is CISC, which is complex instruction set computing. So basically, when it goes to the processor of ARM has a much more reduced set of instructions that can be run. And that works the following way. The compiler, when you compile to ARM, it will have a greater complexity before the compilation, and it will reduce it when it goes to binary. And in AMD and Intel, when the compiler generates something, the complexity is a lot more complex. It's greater. So you can ask yourself, where do we run ARM right now? This is not very used, right? But probably in this room, everyone, you have mobile. Your mobile, 99% of the mobiles are running in ARM. So probably you already have one near you. Single board computers, Raspberry Pis are ARM-based. Laptops, Apple has fully committed an ARM architecture. M1, M2, M3 CPU chips are all ARM-based. And cloud servers, we have Amazon, for example. The ARM instances are called Graviton instance types. And they have, not in every data center, but they have started to have a lot of ARM servers running in the data centers. So why should we change to ARM? We already have AMD or Intel running in our cloud. Why should we change? Well, one big reason, sustainability. Talked about it in the sustainability also last year about it. And ARM is using, since it's using a reduced instruction set, it's one of the reasons also that the electricity that uses the CPU is a lot less than the Intel one. So less electricity means less harm also in the earth. There is a, I'm not sure if it's a trend yet or not, but there is a type of architect decision that's called the frugal architects, which is basically a set of instructions of how to do cost-aware, sustainable, and modern architectures that you take that also into account and not just scale up 1,000 CPUs in order to do whatever you want. And well, if the previous ones didn't manage to convince your manager, that may confuse him. It's a lot more cost efficient, means less money to spend on the infrastructure. And you can, of course, ask yourself how much less money. So I took the liberty of taking from the AWS the instance types. Those two instance types are same CPU number and same memory. While we're doing the transition to ARM in the trains, we are also reducing the CPU because the Postgres are memory intensive workload. So we managed to reduce the CPU also. But let's take the same example. Let's take these two. And there is also in ARM, there is R8G, which is a newest generation, but I'm taking the same generation just for better comparison. And because I'm lazy, I just ask ChatGPT to give me the percentage, and basically the numbers say that it's more or less 20% cheaper, the AMD, with the ARM from the AMD. Okay, so the how we're going to transition. When I'm talking about transitioning, of course, I'm talking about Kubernetes. We're cloud native. Of course, everything runs in containers. So we're talking about the application runs in a Docker container. Our containers run in Kubernetes, and our cloud supports the ARM architecture nodes. So that's the setup. And the process we are going to use is we're going to build the Docker images first locally using multi-architecture. Then we'll update our continuous integration in order to build / release the multi-architecture images so that we have them in our remote registry. We're going to add new ARM nodes on our Kubernetes cluster, and then we're going to gradually shift pod by pod to the new ARM node pool, and then finally we're going to remove the AMD nodes. That's about it. So let's go with the demo. Let me put a little bit here. The demo, I'm going to do it with this repository. So I'm going to deploy an echo server. Echo server basically is a server that simply runs listens in a port and waits for a command, and what it spits out is basically the architecture that it's running on. And the code is very simple. It's this main Go. It's written in Go. I'm not going to go through everything, but basically the output that it gives is this echo text, which is basically the runtime Go arc. And it does it by running this command here in a MOOC here. And I have a make file so that I can make my life easier with all the commands that I'm going to do in this demo. So let me go to the console. If I do a make, I have a very nice helper here that displays all the commands that we're going to do. Let me do a go run first, really quick, to show you what it does. I'm going to split my screen so that you can see it. It runs on 5, 6, 8, 7, 8. And you can see that my architecture is AMD 64. And now I'm going to just build it. And I can build it as AMD. Basically, I'm just adding in Go, you can cross-build the binaries that you want from one platform to a different by just adding the Go architecture that you want. So if I want to go build the ARM in my machine, I just need to do it like this by just adding Go ARM here. And the output here is these two files. And you will see that this file is macOS 64-bit x86 64. But if I check the other file, you will see that this is an ARM 64 file. Of course, the first one, I can run it in my machine. It works as the same as before. But if I try to run the ARM, you will see that I cannot run this in my CPU because I don't have an emulation here. But what I do have is I have a way of building this image in a Docker container, and my Docker, I can emulate the ARM on a Docker container. So in order to build this, normally you do a Docker build and you just build it in your own platform. But with Docker build X, you can build also with multi-platform, and you can do it with this format here. So basically what I'm doing here is I'm building both the platforms, and I'm creating one image that contains both platforms inside. And once this finishes, shouldn't take long. You can see that both of those are running in parallel. It has here the Linux AMD and the Linux ARM. Okay, one of them finished, the AMD. The ARM is a little bit slower because it's emulating. It should be cast before, but anyway. Yeah, I can show you the make file here. The Docker build is doing this command. And what we're going to do next is we're going to do a Docker run. And with this command, you can simulate, we can run in a specific platform in AMD, and with the ARM, you can run it in a different platform. And once this finishes, we're going to push it to the Docker images registry. I have a registry in GitHub repository, in GitHub registry, which I can show it to you here. If you go to the Echo server, you will see that there is packages here. Packages here. And you can see that there are images that have been pushed in this registry here. Oh, come on. We can skip it until it finishes. And once the image is there, what you can do in order to see if the image is multi-architecture, you can do a Docker build image tool inspect. And let me do this, Docker inspect. And you will see that the image here, it says there is a platform for AMD and there's a platform for ARM. So this image is multi-architecture. It has both architectures here. And yeah, let's continue. Now that we have the image, because I already posted before, I'm going to go to Kubernetes and I'm going to deploy it. And I have an ingress and a service that is already there. Let me show you. So I have this server, Echo server service, and this Echo server ingress that is running on this port here, on this IP here. So if I do, and I have the pod that is already running, but I will also deploy it so that you can see it. Normal deployment, it's a deployment without any configuration. And once I deploy this one, you will see that this one is running on a node that is called AMD. And if we go and see the nodes, I have already created this cluster in Google Cloud. Let me show you the Google Cloud also. And it has two node pools, one for AMD and one for the ARM. No, that's not it. Here in this multi-arc demo, I have for nodes, I have one set of AMD nodes and one set of ARM nodes, just one instance. And you can see them here. And the thing that you can see here is if you check the Kubernetes.io arc, you will see that one of them is AMD and the other is ARM. And by default, this comes with taint, which is this one here. This taint, which basically this means that if there is no toleration for this taint, then nothing is going to be scheduled on this node. So only explicit workloads are running on this node. And this is why when I deploy the pod, it goes to the AMD directly. So if I want to run it in ARM, I will need to do it with this way. And we have here two things. One is the toleration, which means that we're no longer restricted from the toleration and we can run things in the ARM node. But apart from this, we also need to add a node affinity in order to instruct that this deployment needs to go to the ARM node. And this you can do it with this part. And I'm just going to run it, apply it in the directly. Yeah, this one. So if you go and check the pods now, you will see that the deployment is rolling restart. And once it finishes, you can check that this pod is now in the ARM node here. And if I do a curl, you will see that it responds with ARM architecture. And if we go back, this is the build, it finished. And let's do the make docker push. So basically with this command, you can push also the images that we created locally. And they are already pushed. And the last part is if we go to the GitHub repository, I have also created one workflow, which basically builds the images from here. And this workflow has a little bit of extra configuration, which is this part here. Where is it? The platforms for this step, for the build and push of the Docker. We instruct the platforms to be AMD and ARM. And this way, when something is being pushed here, it's compiling and it's pushing the images multi-architecture to the GitHub registry here. And here below, you can see the summary and the build information here. So for when something is pushed in the main branch, it names it with the revision number. But when something is released, for example, I can go and do a new release here. I'm going to v101. And I'm just going to publish this release. Tag name, create new tag. And basically this is triggering another build, and this build is triggering with the version v10, which you can see it in the packages here. Again, this command. And you will see, for example, this number is being done from that Git tag that I did. So if I go, what's the name? I can, for example, do a Docker pull of 100. And it pulls the image from there. And that's about it. Hope you liked it. If you have any questions, well, you can ask me or you can find me afterwards and we can discuss more in details. Yeah.
Yeah, so at the beginning you explained about the benefits of the ARM architecture. I assume that there are some kind of workloads or situations, use cases where ARM is absolutely clearly suitable, for example, mobile phone, less consumption, less power. But in the data center, for example, what are the workloads where ARM is more suitable, ignoring other costs a little bit? What are the ARM specific workloads? Maybe some examples. And what are maybe some examples of workloads where AMD, Intel actually are more suitable?
Yeah, good question. And I didn't mention it before. You're right. Since the compilation is different, the instruction set is different, there is no way to make sure beforehand what is better and what is running worse as you said, like you need to do tests basically. So for your own specific case, you need to run tests, performance tests, and make sure if they are better or not. In our case, we did run tests. Actually, we're in the process of deploying this in production, and we didn't run the tests yesterday, and they came out perfect. So there was no performance loss. Everything was running smoothly, and so at least from my side and from our experience, Postgres runs very well and is suited very well for ARM. Maybe it's specific for our case, maybe it's not, I'm not sure, but from our tests, I can see that it runs very well. But as you said, maybe your case doesn't fit well in an ARM CPU. You need to do tests. That's the only way that you can make sure about it. And yeah, I would say that's about it. There's no rule. Maybe, I don't know, if you're running like actions or with Bolsa, buying and shares or something you very need to be performance-wise, maybe it's not the best one, but I haven't seen any performance loss in our case. So I don't know any rule specific about what type of CPU instructions are better or not.
You went into more detail about like what was the test suite that you guys did for understanding if moving to ARM is
What are
suitable? Like what did you test? I guess you tested multiple like Postgres versions. You tested CPU memory consumption.
Yeah, we did. We have an end-to-end of the entire platform for the different Postgres databases. But the test I mentioned before, it wasn't run by our team. It was run by the team that runs in production, the biggest database from our infrastructure, and they had the specific tests of performance that simulates the entire production site. So it's not just running Postgres SQL commands from our side. Yeah, any more questions? Okay, well, you can find me afterwards if you have any more questions. That's about it. Thanks.